Welcome back. We are continuing with section 7.2, and in this section we are using these four formulas that we kind of introduced in the beginning of this section, and these are what we call the sum and difference formulas. These are for sine and cosine of sum of two numbers or two angles, on sine and cosine for difference of two numbers or two angles. And you can see I rewrote them over here. You can see it at the beginning of the section as well. The sine of A plus B is sine of A times cosine of B. So first angle, so sine of the first angle plus times sine of cosine of the second angle. And to remember these formulas, or to memorize these formulas, you can look at the pattern. So when we have sine, the product of terms are going to be, one is sine and the other is cosine. So when we expand it, this is going to be sine of A. So first step or first term is going to be sine of A cosine of B, then plus cosine of A and sine of B. So note here, when we do sine of A minus B, then we will get sine of A cosine of B minus cosine of A sine of B. And actually, if you notice, the second formula can be derived from the first formula by writing sine A minus B as A plus negative B. So you can apply the first formula but replace the B by negative B. So when you have negative B in the cosine of negative B, which will come here, but cosine is an even function, so cosine of negative B is cosine B. So we get this term. And then when we have, let's say, plus, using the plus sign, so let me write over here, sine of A times cosine of negative B. That's what we are getting, plus cosine of A times sine of negative B. Now, cosine of negative B is cosine B, because cosine is an even function. So using the even odd even identity, we can see that we get cosine of B here, and then sine of negative B is negative of sine B. So the negative will come up here, and we'll end up getting cosine A times sine B. So if you remember one form of these, and you should be able to use your algebra to know that we can write A minus B as A plus negative B. You can figure that out, or just kind of memorize these both formulas. Similarly for the cosine. So now if we saw that the previous example that we did, the values we evaluated were all degrees given in degree measure. What if we are given something in radian measure? Well, basically the idea is the same, that we have to look up for our angles which will add up to the given number or given angle, or which would the difference of two should give us our angle. Before we try to write this expression in the number or the angle as sum or difference of two angles, I can apply the odd function property on the sine, and which gives me negative sine of 5 pi over 12. So when I expand this, I will have the negative sign outside, and then we will keep the rest of the thing in brackets. So now we want to figure out how can I get 5 pi over 12. So the denominator we want to be 12. Now the angles that we have worked with, or whose values you know, are basically these ones. You have pi over 6, pi over 4, pi over 3, pi over 2, and we have multiples of these. In degrees, 30, 45, 60, 90. Now, if you think of pi over 12, 5 pi over 12, we don't have a multiple of pi over 12 in here. So what we do, we can try to do, if we can get two numbers or two angles from these ones, such that the multiples of these will give us, and the addition of multiple of these will give us our number, or maybe subtraction. First we try addition. If we can get something by adding, that's what's easier than doing the subtraction. Notice let us try, well, by the way, so which two denominators will give me a common denominator of 12. So if you notice, the denominator 6 paired with denominator 4. So if I have pi over 6 plus pi over 4, the denominator will be 12. By the way, pi over 6 plus pi over 2, the common denominator will not be 12. The least common denominator will not be 12, it will be 6. So this won't work. Okay, so what do we do now? We try to see what will this, just keeping it this way, what will I get? So I will have to multiply, because it's 12, so we need to multiply this by 2, so we need to multiply that by 2. So we get 2 pi over 12 plus, what do I multiply this with? 3. So 3 up here, 3 down here. So we get plus 3 pi over 12. And when we add, we end up getting 5 pi over 12. So that's it. That's how we do it. So now you can see that the sign of negative 5 pi over 12 can be written as we're dealing with sign of negative 5 pi over 12, and we factored out the negatives, not factored out, sorry, we use the odd fraction property, and according to that, the negative sign we put outside, and some sign of 5 pi over 12. That's what we have. Now I can write the 5 pi over 12 as what we just saw. The sign of pi over 6 plus pi over 4. And now let's use the some formula for the sign. So I'll keep the negative sign outside. And I can write here sine of pi over 6 into cosine of pi over 4 plus cosine of pi over 6 into sine of pi over. is equal to, so the negative sign is still outside, so I need to keep everything else in parentheses. Now sine of pi over 3, pi over 6, right? Not 3. Pi over 6 is 1/2. Cosine of pi over 4 is square root 2 plus cosine of pi over 6 is square root of 3 over 2, and the sine of pi over 4 is square root of 2 over 2, which gives me negative of square root of 2 over 4 plus square root of 6 over 4. So that negative of square root of 2 plus square root of 6 whole divided by 4. Or you can just say is equal to negative square root of 2 plus square root of 6 whole divided by. So this negative is in front, it is not with negative square root 2. Where this negative sign is, has to be put in front of this line. So we are going to get a negative value. Okay, so now we see an example in which we can use a formula in the opposite reverse form. Here is an example. By the way, if you have an angle which is a multiple of pi and you don't know how to write as a sum or a difference of two angles, you always convert it into degrees and then find the two angles whose sum or difference gives you that angle, and then convert it back to radian median, means in terms of multiples of pi. So for example, this 5 pi over 12 was how many degrees? So we can multiply it by 180 over pi. So you will do your math, the pi and the pi cancels out, and you will get 75 degrees. And we know that 75 degrees we can write as 30 degrees plus 45 degrees, which means you can write it as pi over 6 plus pi over 4, and that's what we got. Okay. So you can do this and then plug in and do the computation that I showed, or you can, if you can directly find multiples of pi or the angle by these pi over 4, pi over 6, pi over 3, pi over 2, whichever works, that we can do that. Okay, another thing that we are going to do now is be able to get an answer using these formulas in the reverse order. For example, we have cosine of 10 degrees times cosine of 80 degrees. Now, we don't know that what is cosine of 10 degrees and what is cosine of 80 degrees because these are not we didn't put them on the unit set. And then we have minus sine of 10 degrees and cosine of sine of 10 degrees and sine of 80 degrees. Note here, the angle is 10, the angle is 80. Here also angle is 10, angle is 80. So if thinking in terms of x and y, what you have here is cosine x cosine y minus sine x sine y. So since the product consists of same functions, So it means this is a cosine. And cosine of the first angle, which in our case is 10 degrees. And then because of the negative sign in the middle of the two terms, this is negative sign, so this will give me a plus sign over here. And then we have 80. So this becomes 90. So I get equal to cosine of 90 degrees. But what is cosine of 90 degrees? It's 0. See, now from here, you cannot imagine that you'll get a 0. But when we apply the formula, that's what we are getting. Now if you plug in calculator, because these values you cannot find without the calculator. So I believe when you do the calculator, you might not get exact 0, but you might get something close to 0. Let me see. Let me check what do we get. Okay, while I had put my phone on restart. While it restarts, let's finish the next one. Look at the next problem. And this one is saying we have sine of 13 pi over 15 into cosine of pi over negative pi over 5. So our first angle is 13 pi over 15 and second angle is negative pi over 5. And then we are multiplying by different functions. Product is of different functions, which is the sine of something. So this can be written as sine of 13 pi over 15. Now, will I have plus or minus? Well, remember in sine, whatever is here is going to be here. So plus, and the second one is negative 5. So plus negative 5, so actually would be 13 pi over 15 minus pi over 5. But anyhow, negative pi over 5 and parentheses grow. But this becomes 13 pi over 5 minus 15, 13 pi over 15 minus pi over 5. So taking the first I will write it as sine of 13 pi over 15 minus pi over 5. So 13 pi over 15 minus pi over 5 is what? 13 pi over 15 minus pi over 5. So we can see that the common denominator will be 15. So I need to multiply the second term, top and bottom, by 3. We end up getting sine of 13 pi over 15 minus 3 pi over 15. Which gives us sine of, so common denominator, so add the term and we end up getting 10 pi over 15. Now 5 goes into both, so we get sine of 2 pi over 3. Now we know we got a number whose sign we know. So sine of 2 pi over 3 is the same as sine of pi over 3, which is equal to square root of 3 over 2. So this will we evaluate the expression. Okay, I'll stop here And then we'll continue with the next set of examples.